Our previous examples with futures, when we introduced them, were actually quite simple. All that they did was print. So, turns out the future itself is intended to represent a calculation, something that is going to give us back a result, but the result might not be ready yet. And in fact, you can see that if you look at the future type takes a type parameter, and in this case, because print line just produces a unit, this is a future of unit, which isn't a very informative calculation. It would be good for us to actually make a future that calculates something and look at how we deal with the value that is calculated. So we're going to make another future. I'll just call it F2. And I am going to make it so that this future does a calculation of Fibonacci numbers. So we put a slow recursive Fibonacci calculation in our parallel collect. I'm going to use it here. And so I'm going to say for I in 1 to 30, yield the fib of I. And now, this should be parallel collect. Dot fib. Okay. Now if you look at F2, F2 is now a future of index sequence of int, because the yield on the for loop is going to give us back all the different ints that are the different Fibonacci numbers up to 30. Okay, straightforward. How do we get to that value, though? Well, if we go and we look in the API, we'll see that there are actually, let's go to future here. There are a number of interesting methods here, and the one that you might be tempted to call is this result method. But it turns out that it specifically tells you this method should not be called directly. Use await.result instead. Okay, we'll go and we'll look at that later, but even using this is not the ideal way to do things, and the main reason is because it blocks. Okay, it stops the current thread and sits there and waits. If you want to just possibly check to see if it's completed, you can call isComplete. You can also call value, in which case you'll get an option of the type or of the result, and it'll be none if the calculation has not yet completed. You'll notice there's an option of try. There's also another method here called onComplete, and if we look down here, you'll see some methods that have names you're familiar with. For each, map, filter. We can call these methods on futures as well. For example, if I map a future to another function, this function will be applied when the future is done, and the map gives us back immediately a new future which will have the result after that second function has been applied. There's also a flat map which can be used to compose functions that give you back futures. We can look real quick at for each. For each is probably the simplest way of doing things. So we can say f2 dot for each, and now this will be called with the value from the calculation, but only after the calculation is done. And this is a non-blocking call. So this is kind of scheduling something to happen later on. And if I just want a print line, this is basically saying that when F2 has completed successfully, we're going to do a print. We can run it, and sure enough, there is a vector. I still have a thread sleep for 5 seconds that keeps it running for a little bit longer, but there you go. Okay. This only happens if the calculation is completed successfully. Well, what if the calculation winds up throwing an exception? What if something goes wrong inside of whatever it is that the future is doing? Well, in that case, we probably want to use, instead of the for each, we want to use onComplete. And you'll notice the value here also, both onComplete and the value have this type called try. So try is in Scala.util, and in some ways it's similar to option. Option had a sum and a none, either for representing a value or not. try has a success and a failure. So if the calculation is done successfully, you will get back a subtype of try called success. And if it fails, you'll get a subtype called failure that has the exception that caused it. So instead of using our for each, let's see how we could do this with onComplete. So onComplete, and I am going to write this using the partial function syntax of Scala. So I'm going to have one case for success of, I'll call it n, in which case I'm just going to print line out n. And then another case for failure, which will get an exception, and I'll print something went wrong, and I'll just append the exception on there, which will give us something of a string. In order for that to compile, I need to do an import, and you see we get Scala util failure and Scala util success. Once again, I can run this, and of course it prints out the value there because this did not throw an exception. I guess I could force it to throw an exception. Throw new runtime, no capital T, runtime exception, and now if we run this, something went wrong, Java runtime exception, bad. Okay, so you can see how the onComplete gives you the option of dealing with both the case where the calculation was handled properly and the case where it was handled improperly. Like the for each, this is basically scheduled for the time when the F2 future is done. It doesn't happen until then. Okay, so we can chain on our futures and make it so that one thing happens after another, and we're not blocking. We'll come back in the next video and we'll talk about how you can block. And maybe you need to do this, but you should definitely put it off as long as you can. We'll see how we can actually do that.